Welcome everyone to the Inside Scoop episode 71. This time we have Yaseen here. Hi there.
Hello, hello. How's it
And
going?
we have Oscar co-hosting this one.
Hello.
And today we are going to interview Yaseen a bit on his final year project, the university honors project here in the United Kingdom, about how he was using AI to detect rocks on the moon, pretty much something like that. Anyway, cut to the chase. Your project is called Detecting Boulders on Lunar Surfaces, Yaseen? What is that?
On lunar surfaces, yeah.
Lunar surface? That's
So I can start with
that's some space stuff. What is that?
yeah. So basically, I can start with like defining what a boulder is. So a boulder is pretty much like rock fragments that are scattered across like planetary surfaces. So these can be from like asteroid impacts mainly. And so my task was to detect these rock fragments and pretty much find the size and position of each boulder. And this is using computer vision and like AI and deep learning.
So you have made a system
Yeah.
which sees rather.
Mhm.
So it's
Sees,
like, does it have a
like-
camera or?
So pretty much it's a set of images. So like I would use this image taken by like a space probe, and then that image will be sent to like a neural network or like a deep learning system. And then the output would be an image with a bunch of boxes showing the detection of each boulder, pretty much. And to train that, I used kind of like synthetic images, so images that were used, like not real images, pretty much. Images that are kind of like generated from like a 3D modeling software. And to test the system, I use real life images that are like taken by the Lunar Reconnaissance Orbiter. So like images taken by space probes. It's pretty hard to explain, but
Yeah. Well, I kind of get it.
yeah.
So you would use that for like spacecraft guidance or like landing or is it
Right.
just
Yeah.
like
So after the output, so after all of the positions and the sizes have been calculated, and like you see these boxes that have been detected on the image, if you can like kind of image that in your head, after the output, all the coordinates and all the sizes are used to like actually model a 3D surface, because the main use case of my project is not actually to help like probes and spacecraft land on the moon. It's actually help generate synthetic like 3D terrains, because it's kind of like tedious to like draw out every rock fragment on like a 3D modeling software, like for example, let's say like Maya or like Blender, for example. Imagine drawing each individual boulder. It takes quite a lot of time. So this system automates that process.
it pretty much gives you a moon which has
Yeah.
like it's like, is it like 3D, almost 3D scanning a moon, something like that?
Kind of like that, yeah. So the main objective is mainly rock fragments. So like all these boulders, right? We mainly want to like scan those and then place them on like a 3D model. The craters and the rest of the terrain is kind of like just you just like, it's kind of like just there already, if that makes sense.
Right.
So all it is just like automatically defining these boulders on this terrain, on this 3D terrain. And then like the use case of this would be to, for example, like let's say like you're a researcher and you want to like actually do some simulations. It's quite tedious and quite long for them to like make the models themselves. They would want to get the simulations and all the testing done like straight away. So instead of like them making the model, why not have like an automated system to do that for them?
Right. So but they want the researchers, right? They want the
Yeah.
model to be modeled from the real moon, like not just randomly
Yeah.
generate those boulders.
Yeah, so they want an accurate model, so they can run like space landings or whatever they want to need to do. Because like imagine if you want to land like a spacecraft on a boulder, like that's gonna fail, that's gonna crash. You want to land on a flat surface, and And having these simulations beforehand can like save a lot of money. Like imagine like you just launch a spacecraft or a rover out of nowhere without any testing. Like that's gonna probably fail, and it's gonna waste a lot of money. So like having these simulations and creating these simulations in a quick manner is very beneficial.
That makes sense, to be fair.
Yeah.
Could it detect aliens?
Yo, I wish if I had enough images of aliens, maybe. But nah.
No.
Maybe in the future. Who knows?
It could be like a patch, like a beta patch.
Yeah. Yeah.
Just like detect
That'd be
aliens.
nice. Oh, detecting UFOs, that'd be pretty nice. Like
Yo.
real time footage. Yeah. That'd be sick.
And this was achieved by, just to get into, I guess, more technical part a bit,
Yeah.
machine learning, AI.
Yeah.
What's it?
So pretty much, so the system is comprised. Let's start off with like the top-down view. So,
Right.
system is comprised of like, so the backend, which consists of like the AI, the deep learning, machine learning, and then a front end, which is where the user would actually input the image for the system to like use to detect. And the deep learning is computer vision, and it's kind of hard to explain. So in deep learning, the reason why it's called deep learning is because the network is comprised of many layers, right? So generally the consensus is more than 3 layers, the network. And this network is very complex. So it has different architectures. So the architecture I chosen was faster RCNN, which consists of a feature extraction module, what was it, region of interest, like finding the region of interest. And then the final layer or the final block of that deep learning system is a classification module where like the image is classified as boulder or no boulder, if that makes sense. And also the bounding boxes are also like drawn on, if that makes sense.
Right.
So the network, so to make it simple, the network is split into 3 components: feature extraction, finding the regions of interest, which means finding the regions finding the foreground objects, the regions that we are interested in. So not actually pinpointing the actual boulder or the rock fragment, but finding the region where we are interested in, right? And then the last module, or the last part, is the classification, is the also the bounding box output as well. So the classification and the bounding box output is the last part, the classification part.
Right.
Yeah. So that is the faster CNN architecture. And there are many different architectures I could have chosen, but this one was kind of like the one that made the most sense.
And how much computing power does all of this process require once you have the model trained?
Okay, so training takes a lot of power, takes a lot of GPU power. Once the model is trained, you can save the model into a file. And
Okay.
the file is, I use PyTorch, so the file is ending in .pt. And that file saves all the weights, all the trained weights, all the nodes, all the biases. So all the values, all the values are needed, right? Or all the trained values, for example. And so that file gets loaded again into a faster RCNN again, but this time with all the weights and all the biases, the values of those trained, all the trained values are loaded. And then once an image gets inputted, because we have all the weights and the values and all the biases already like pre-trained, it doesn't take that much power. It only takes about on my laptop, it took about 10 seconds to predict everything, pretty much.
Right.
Yeah.
So you theoretically could implement this into a lunar lander or something with a bit more processing power, and then have real time imagery
Yep.
to track.
So as long as you have all the weights and biases saved from the trained values or from the training, easily, like a CPU would handle this. Like even my laptop, just like Intel i5, pretty much handled everything in like 10 seconds.
So is that pretty much how AI in general works, right? So you train, like it doesn't matter what it is, like Boulders or I don't know if you've seen Silicon Valley, the TV show where one of the guys made a hot dog not hot dog application which tells you if it's a hot dog or not.
Yeah.
Like, so you pretty much, well, you have to train it, right?
Yeah. So first you have to train it.
How did you said you were manufacturing the images, like creating boulders yourself or something?
Yeah. So the data collection was the most annoying part of this project.
Okay.
It took about 70% of my time.
Wow.
I'm not kidding. I'm not joking. No, it took most of my time. Like building the network itself was quite simple, but data collection was very hard. Like first, so because there's not enough images of like the lunar surface, it's very hard to come by, and we need images that are close so you can see the boulders. Because it wouldn't make sense to have like a far away image. There's like the boulders are non-existent, right?
Oh, okay, fair.
Yeah. So to generate these images, I used a software called Pangu, which stands for Planet and Asteroid Natural Scene Generation Utility. And it's a software that's used by like researchers to like do these simulations, like I mentioned earlier, and to like 3D model like terrain. And I use that software to actually generate like a random lunar surface or a random surface of my choice, right? And then use its camera to like batch generate like thousands of images. So the camera would move along the surface and it would take an image, move to the next step and take an image, move to another step and take an image. And this happens like thousands and thousands of times until I get enough images, if that makes sense.
Yeah.
And once I got these images, I had to label them. Now, labeling was the hardest part because you would need to label like to label the data, like, or to feed images into a network. You also need its ground truths, which means you also need like you also need to tell the network like what is the actual like values. What does the network need to do? What does the network need to predict? If that makes sense, right?
Yeah.
So I need to label like every individual boulder to its exact point.
God.
Yeah. Otherwise, the network would not know like where each boulder is or where to, like where it won't know where it failed, right? And so to label each individual boulder, I use some like image pre-processing. Like I use some image pre-processing technique because imagine doing this like manually. Imagine labeling every individual boulder for each image manually. It's going to take time, effort, and it'll probably take like the whole 3 months that we had for this project. So so the way I did it was I used like I automatically did it with OpenCV. So for each image, I removed the background and left the boulders like visible, right? So imagine like imagine removing the background and making the background black and then leaving the boulders like visible, like the gray boulders, these like little circles visible. Then I use something called contours, which means that it draws around each feature in the image. So wherever wherever is like not black, for example, not a black or not a background, right? Wherever is a boulder, it will draw around it, kind of in contours, in a contour form, right? And then by using like draw a rectangle, right? It would draw the rectangle around these like what's the word?
These boulders that you have that are extracted from the background, you mean?
Yeah. So these boulders are extracted from the background, yeah. So it would draw a bounding box around these boulders. Because the contours find like the colors that are like vibrant, for example. If that makes sense.
They're different than
they're different than the background itself. They're different than black. But so whatever is different than black, then the contours will find it. Then it will draw automatically draw a rectangle around it in each individual boulder. And then that's my truths. My ground truths, what the network is looking for is these bounding box coordinates, right? So I extract these coordinates, put it into a CSV file for each image. So for each image, I have a bunch of coordinates, bounding box coordinates, in a CSV file. And this is what the network is looking for, to like say that it's failed or not failed, or if it's close to its prediction or not close to its prediction, if that makes sense.
So this is like if you took a young child and you went to the park and you were like pointed your finger, this is a squirrel.
Yeah. Pretty much. This is
an ant.
Yeah. That's pretty much how it is. And that's like the data collection process. But like this was a trial and error process. It took so long. Like I had many different like versions of doing it, trying to like, I don't know, use the camera from like, and like pinpoint each boulder, and like, you know, it was very, very convoluted.
But that's so smart, genuinely. I would imagine, because like I've always heard about training the algorithm, right? But I would always imagine that all those thousands of pictures that you've just mentioned, you would literally need to like point out every single boulder yourself. But then the way you explain it is just like, like remove the background, you know, like tell them what's left is a boulder. Wow.
I was kind of stuck because like if I did not get past this process, how am I going to train? Like how am I going to finish this project?
You would probably ask for funding from university and go on Amazon Mechanical Turks, which is an online service where you can offload mechanical work for and like just each picture is worth 10p, and you would pay 10p for each picture, and people would like.
I think I have £100 to spare, man.
Let's say get some finance from the university, being like, oh well, there's no other way.
I mean, I probably could have got help from like my advisor, because I'm pretty sure he mentioned that like if you can't do this, then like we can like try and help you out a bit. So my advisor actually helps me a lot with that, to be honest. Like he gave me a backup option, but like I found a better way of doing it, which was a lot easier and a lot faster.
Yeah, that's true. So now, are you going to continue this project at all after you were finished? Were you considering on improving it, or is it just like a uni project and you're pretty much done with it?
I think I'm pretty much done with this project.
Right.
I did learn a lot for sure. Like especially on how hard it is to label data.
Damn. That's weird. Like every time I think about AI, I don't even think about it. I'm just like, oh, AI must be the hardest part. Must be like coming up with the algorithm, or how do you train it or something, but not the data.
Yeah, the data is like messed up. I mean, as long as you get like the general concept of what AI is, if you don't have the data, well, you can't do anything.
Right.
You know? And like me going into this project, I thought I was going to get the data like already prepared for me, but I'm glad I didn't, because like it taught me a lot about like it taught me a lot that it's not just about the AI itself. It's also about like how you're gonna approach labeling all the data, and how hard it is as well. It's not easy.
So besides learning the labeling, what would you say was one of the main things that you've learned too? Like
also actually just like deep learning in general, like computer vision. Because this is a very new subject to me.
Right.
Like I did dive into like machine learning AI previously in previous years, but like I never actually fully made a project or actually applied it. And this gave me a purpose to apply what I've learned. And like it made me realize that like it's not all about theory. It's all about like applying yourself to that theory.
Right.
And
So it sounds to me like you're more of a top-down approach, kind of like make a project and learn things.
yeah, so yeah, I learned a lot more like just actually diving into like whatever machine learning or whatever deep learning library. I use PyTorch.
Mm.
And like just messing around, playing around with it. As long as you got as long as you got like the basic fundamentals, you can just go in and like try a bunch of stuff out. Learn what tensors are, learn what a layer is, in a network,
Yeah.
and learn how to actually build it layer by layer.
So, would you call yourself more of an engineer? Are you more interested in applying the knowledge of the scientists and making applications with it, with the knowledge, or would you be interested perhaps in also exploring like the nature of how AI works and such?
I found it more beneficial for me personally to be more of an engineer rather than exploring the subject. I'd actually like to do a bit of both, but I'm leaning towards more of the engineering side.
And do you have any projects that you're interested in doing in the future relating to this stuff?
Let's see. I would like to like I would like to like I don't know, it's like open my door automatically with my face. I would like to do that for some reason. I don't know why.
That's kind of cool.
Yeah. So like some futuristic Tony Stark kind of thing.
Man. What if I take a picture of you, make a cutout, and come up to it and just wave it? Would you use some sort of like a laser dot projector or something?
Yeah, that's the problem though. That's the thing. Like, how would you get around with that?
What if you kind of like made it so that your system would ask you to turn your head sideways?
Oh, sideways,
like,
yeah.
And then you would teach it all of your head's features rather than just the front.
Just
the
the front. Yeah, that would be also like, or the eyes. The eyes is also like something that I was looking into, like opening, like or like, because I think I'm not too sure about this. I need to double check this. But like, I think everyone has unique patterns on their eyes, and I think people are looking into this, where they can use these patterns on the eye to like actually use that as biometrics instead of just a fingerprint.
It's like the spy movies.
Yeah.
Man, literally, all these spy movies where they have the guy like comes up, scans their hand like a palm, then scans their eyes, where you see someone getting killed, and then the bad guys take that guy and like open their eyes and try to like scan it on the scanner just to pass through the door and stuff.
And even the hand structure as well, like the bone structure in the hand, they're actually looking into it and seeing if that is also like an application for like biometrics, because that can also be unique to each person. But also I'm not too sure about this, like, but it's quite interesting though. Like,
I'd imagine the more features you use, the more obviously the more steps of a failure that could happen. If now our authentication became like from our elbow all the way down, like it would scan our veins, it would see like our fingers or all of that, and then imagine you like break something off and it's like, rip,
yeah
now we're stuck outside your room because the door doesn't open.
Oh no.
Like, no.
You lose a finger, that's it.
Oh, that's a rip, dude. You need like a forgot password, so you need a button that says lost finger.
Oh no.
Oh my. But honestly, I'd probably need to think about something like that. Would you consider a future career in this, or did you figure out that it's like not necessarily something you would be too interested in?
I'm actually very interested in the future career in this. Yeah. I don't know, like, since that I've like been through the pain of this, and it might be a bit easier like down the line, like since I've got this skill, I might as well use it, and I actually like enjoy it, like now that I think about it. So
you could leave it up to the data labelers to label the data. You could just be like, nah, I'm not doing this anymore. Nope.
That's the thing though, like most like AI jobs, all of it is data. Like if you're gonna like start off as like a like a machine learning engineer or something like that, they're just gonna give you data to handle. Yeah. But like I think I can tackle that on now since I got the since I got the experience, a little bit of experience in it. So
So just kind of like
You've
building
got a
up to
story
it.
about this, Marius. About the guy doing the rice and the guy doing the fish.
Yeah, as I say, it's like building up to it.
yeah.
The kind of Japanese chefs kind of thing. You do start off as a towel handler. It's the Japanese sushi way, or rather, just the Japanese way, where they usually spend their lives in a company like dedicated to one craft, where you start off as just a guy who handles the towels, and then in a year or so they're gonna let you like do something else in the kitchen because you're gonna be learning all that, and then
Like a step by
eventually,
step.
yeah, it's a step by step. Then once you know how to handle the towels well, then they're gonna let you in on working on the rice. Then you're gonna work with the rice for like 10 years or something, until you actually get to the point where they allow you to cut the fish for the sushis. And it's like a structure of moving up. So I think we were even using this example in cybersecurity. I don't know if we had a podcast about cybersecurity jobs, but I've learned somewhere that you start as an analyst, so you kind of look at logs and you kind of monitor for suspicious activity or something like that. As again, I'm not a cybersecurity expert, or I don't work in that field, so I don't know. But from what I saw, people sharing their career advice, etc., they said you start off as like a guy down there. It's like a clear ladder. So I would imagine with AI, and I don't know. Actually, when you honestly think about it, maybe that is the way you would like to start, though. You wouldn't want to jump straight in as like a fresh grad, maybe. Wouldn't jump straight in into like the difficult part of like of it. You might want to have senior engineers like who have worked in this, or again, I don't know what that is, but
Yeah. No, I agree. Like, because there's so many levels to it.
yeah.
So, like, also like tweaking and like everything like that. I would rather leave that to like someone more experienced before I get there. You know. So yeah. No, that makes sense though. Like, working your way up is a lot easier than like putting yourself in the deep end.
Yeah, especially with something, if assuming you're working on some bigger company with like more impactful algorithms or something that people depend on or whatever.
Yeah.
But have you tried? I don't know. Have you tried looking for jobs like that? Because I don't think I've seen many like AI jobs out here for graduates. They probably not even looking for graduates.
I've seen one or two. I did apply for them. I don't think I haven't got a response yet, so I'm still waiting on that.
God damn it.
But yeah, I've seen a couple, but they're not really like popular. Not.
Do you think they're more kind of a sector for people where they expect you to have like a master's or a PhD?
Yes, that's probably what. Yeah, that's the thing though. Like, they would want a master's or a PhD student. But I'm not looking forward to doing masters for this. I'd rather like, yeah, I don't know. Like, I'd rather like, it's complicated because like I'd rather like show off my portfolio maybe.
Yeah.
Show them what I can do, and like maybe get some sort of like online certificates. Because there's plenty out there, like TensorFlow are doing it. I'm not too sure if PyTorch is doing it. But there's like Coursera. There's like a lot of online certificates that you can like show that you have the skill. And also you have to show it in the interview as well. So if you can show it in both ways, then I'm sure that they would. I don't know. I'm not too sure, but masters is definitely like a good like certain path to get to where to like, for example, like a machine learning engineer or like a deep learning engineer. Like, masters is definitely a thing you would want to consider doing for sure.
Right. But you could
But
work a normal, regular developer job and like on the side do AI projects and just build up your name by that or something.
Yeah, I could also do that. Get a few certificates along the way. Because I feel like with this like computing degree, there's a lot of like also opportunities out there like with certifications. Like, you don't need to do masters all the time. Like AWS certificates, for example. Like, there's plenty of certificates out there that you can show to like employees that you got something.
Would you consider doing any of them? Because I mean, I know that there's a lot of them, but like, I look at them like, I don't know, maybe I don't need it. You know, it's like,
Yeah.
do I really need one? If the job does not
Yeah.
require it, then like, like, I don't
Well,
know.
I'll do it if the job requires it, for sure. I mean, I guess I'll do it. Like, why not?
Not fair.
Yeah. Like, I'm definitely considering the TensorFlow one for the future. But yeah.
Yeah,
Like,
I remember wanting to get one of those cybersecurity certificates, but then I asked someone who has been through that, and they're like, "Oh yeah, it's not bad. You know, you can do it in 2 days. I did it in like a week. It was like a boot camp, blah blah." I
yeah.
was like, "Oh, that sounds good. I want it." Oh wait, how much does it cost? And they're like, "Oh, yeah, it wasn't bad. It was around £4,000." I'm like, okay.
Oh no.
I'm like, okay, never mind.
Wow.
I'll just do my day job, dude.
Yeah, that's the thing. You might need to pay a bit.
Yeah.
However, like, I mean, there's some free ones out there. I know my dad, like, he's done some like, what was it, test-driven development certificates, and now he's like doing testing. So yeah, like you can get away with like not doing any master's degree.
It's
For
definitely
sure.
good to look for alternatives. Yeah.
Yeah, but masters, like, for certain things, like, it'll be good, like good track. It's a good path. Like you define your path. Like,
Yeah,
you know.
for like a clear. Yeah, I mean, if there's a ladder in a field, you probably have to start down there. You know, just get a bachelor's, get a master's, then get into the lower, like like the data handling department of AI, and then maybe climb up. Like, I would imagine there's a clear structures or whatever. But
Yeah.
I feel like there's potential for you, and if you wanted to get into AI, you could make your software detect aliens, and once you actually
Yes.
once you do that, I can supply you with some sketches of what I think an alien might look like. I can position them around on a lunar surface, and then we can be like,
Oh yeah, dude.
create our
That'd
own.
be amazing.
Yeah, and then like make a real time detection kind of thing,
And then find the first aliens.
because no one's actually done that. I don't think, they are
No,
looking
no.
at photos, but they're not sending AI.
Imagine it was like a false positive, or like, was it false negative? I
False
forgot the
positive or
word.
something.
False
Yeah.
positive. Yeah, false positive. Where it's like, it just detects something, and I'm like, oh yeah, it's an alien, and it's like, no. It's like I don't know, like a satellite fragment or something.
Yeah, but we would at least have, the press would have something to write about,
Yeah.
We would get
true.
excited, people excited, because now everyone's like so serious, like, could there be life out there? And all the scientists are like, oh yeah, well, there could be, blah, blah. And we would just be like, oh, we found an alien. And everyone would be like, yay. And they'd be like, oh, well, never mind. It was just something. That would be, but still, we did something. Excited the people.
True.
Yeah, the future of AI is exciting. I don't know.
Yeah.
Kind of wrapping up, I guess one of final questions would be, I guess, your opinion. Where do you see AI itself going? What do you feel like integrating it in the society and alien searching and everything like you?
I see AI going to AI is going to kill us all.
That's fair.
Yeah. No, I mean, I don't see them being too conscious. I don't know. That's the question, though. I believe that like, if AI becomes, I believe AI will become like really intelligent, like more intelligent than us. But I don't know if they will be able to think for themselves. That's the question. I don't know.
Right.
Do you think perhaps AI will just be a very intelligent tool of ours that we will use perhaps for specific tasks to solve problems very accurately, maybe?
Yeah, I think so. I think AI will be able to like solve a lot of things very quickly, like things that we cannot solve like in an instant or at all, actually. Because it's got like pattern recognition, like, certain patterns that maybe we'll not be able to detect, but maybe the AI will be, I don't know if it will be like conscious or, like to that extent, but I can definitely see it, like definitely see it mimicking like the human brain, but to like, to 10 times or like 20 times more to what we can process, for sure.
Yeah. In terms of like how how much information perhaps it's able to process. And
Yeah.
and,
Yeah.
yeah.
Right. So in that case, I just before we part, do you have something you want to share, like where people can find you or your project's GitHub? We can put anything in the show notes.
Yeah, I mean, I
or-
got like I got a video to just show this project like visually,
All right.
so I can probably say that. And also, yeah, I can share my GitHub as well.
Right. So we'll put those in the show notes. And other than that, Yaseen, it was a real pleasure talking.
Yeah, it's a pleasure talking to you, man.
Hoping to get you in a future episodes. Talk more
Yeah,
about AI, maybe AI controversies, etc.
For sure, yeah.
And thanks, Oscar, for co-hosting this one. And everyone else, thanks for listening.